Let's take a look at question 13.7d. So this asks us, what reagents would we need to do to generate this alcohol, this tertiary alcohol from this alkene? So we need to add a hydroxyl group and a hydrogen across this double bond, and you can see that this is Markovnikov, Markovnikov addition across a double bond. So for Markovnikov addition across a double bond, we talked about using sulfuric acid, dilute sulfuric acid, or using oxymercuration, demercuration. Well, in this case, what would happen if we used dilute sulfuric acid? So if we use dilute sulfuric acid, what's going to happen is we're going to have some H plus floating around in our system. And if our alkene reacts with that H plus, what do we generate? What kind of carbocation are we going to generate? We're going to generate a tertiary carbocation. So this is a tertiary carbocation. And what's interesting about a tertiary carbocation is that it can't rearrange. There's no way for it to rearrange. So we have the most stable carbocation. Most stable carbocation is not going to rearrange. In question 13.7e, we did see a carbocation that could rearrange to generate a more stable carbocation. But in this case, we have the most stable carbocation possible. So what's going to happen now is we're going to add water across that. So 1 and 2. So we're going to lose a proton. And what we're going to end up with is our product, our tertiary alcohol. So that is why we would use dilute sulfuric acid in this case, because we just add, when we add our acid, we generate the most stable carbocation right away. So let me circle that, our tertiary carbocation. So that's not going to rearrange, and that's why we can use dilute sulfuric acid.